High above the Earth, beyond borders, oceans, and clouds, thousands of satellites race through space at unimaginable speed. They form an invisible web around our planet, one designed to change how humanity connects. This is Starlink, the largest satellite constellation ever built, and this is the story of how it's made.
Starlink is a satellite-based internet system developed by SpaceX. Its mission is simple but ambitious: to provide fast, reliable internet anywhere on Earth. Unlike traditional satellites positioned far above the planet, Starlink satellites orbit much closer, reducing delay and increasing speed. This low-orbit design is what makes global, real-time internet possible.
Elon Musk has never followed traditional paths. When he looked at the satellite industry, he saw a system that was slow, expensive, and designed for a different era. Traditional satellites take years to build and cost hundreds of millions of dollars. That model could never support a global internet network. Musk's solution was radical. Build satellites like consumer electronics, mass-produced, rapidly improved, and launched in large numbers. Engineers worked tirelessly to turn this vision into reality, redefining what was possible in satellite manufacturing. That single idea reshaped the future of space-based internet, bringing global connectivity within reach for millions.
For decades, satellite internet suffered from one major problem: distance. Traditional satellites orbit more than 35,000 kilometers above Earth. That distance caused high latency, dropped connections, and limited speeds. For modern internet use, it simply wasn't good enough. Starlink was designed to solve this problem by moving satellites much closer to Earth, and that decision changed everything.
Starlink satellites operate in low Earth orbit, just a few hundred kilometers above the planet. This dramatically reduces the distance data must travel, lowering latency and improving reliability. But operating this close to Earth introduces new challenges, including atmospheric drag, orbital congestion, and the need for constant coordination. Solving those challenges required unprecedented engineering. The result is a revolutionary network providing global, low-latency internet connectivity.
The journey of every Starlink satellite begins on Earth, inside one of the most advanced manufacturing facilities ever built. This factory is not designed for slow craftsmanship. It is designed for scale. Every process, every machine, and every workstation is optimized to produce satellites continuously and efficiently. This is where the future of global connectivity is manufactured.
Even microscopic dust can destroy sensitive electronics. That's why Starlink satellites are assembled inside clean room environments. Every surface, every movement must maintain absolute cleanliness. Air is constantly filtered through high-efficiency systems. Temperature and humidity are tightly controlled to exact specifications. This level of cleanliness ensures that every satellite begins its life free from contamination. Contamination that could cause failure in space is eliminated before launch.
The physical structure of a Starlink satellite is designed to be lightweight, strong, and compact. Every gram matters in space. Reducing weight allows more satellites to be launched at once, lowering cost and increasing deployment speed across our global constellation. The frame must survive intense vibrations during launch and extreme temperature changes. From the intense vibrations of launch to the harsh thermal environment of orbit. Engineered for resilience, precision, and the future of global connectivity.
At the core of every Starlink satellite is a dense network of electronics. Automated systems place thousands of components with microscopic precision. Sensors, processors, and communication hardware are integrated into a compact design, built to operate flawlessly in the harsh environment of space. This advanced technology powers global connectivity for millions around the world.
Starlink is as much a software project as it is a hardware one. Each satellite runs advanced software that controls navigation, communication, and network coordination. This sophisticated software enables seamless connectivity across our global network. Updates can be sent from Earth, allowing satellites to improve even after launch, something traditional satellites could never do.
Low Earth orbit is becoming crowded with thousands of satellites and space debris. Starlink satellites must navigate safely through this complex environment. Using advanced onboard sensors, they detect potential collisions in real time. Autonomous systems calculate and execute precise orbit adjustments automatically. This protects both the satellites and preserves the space environment for future missions. Starlink's autonomous navigation represents the future of safe, sustainable space technology.
Phased array antennas allow Starlink satellites to steer signals instantly without moving parts. This advanced technology enables precise electronic steering of communication beams. Signals can be directed with pinpoint accuracy to connect users anywhere on the planet. This enables seamless handoffs between satellites as they pass overhead, keeping users connected with uninterrupted, high-speed internet wherever they are.
Laser links allow Starlink satellites to communicate directly with one another. This creates a space-based data highway, faster, more efficient, and capable of delivering internet even where ground stations don't exist. Revolutionizing connectivity, one laser link at a time.
Power in space comes from the sun. Starlink satellites use high-efficiency solar panels combined with advanced batteries to operate continuously even while passing through Earth's shadow. Advanced shielding protects critical components from harmful radiation. Reliable power systems ensure uninterrupted connectivity for global coverage.
Temperatures in space swing from extreme heat to extreme cold. Starlink satellites use advanced thermal control systems to protect sensitive electronics, maintaining stable internal temperatures in a hostile environment. Advanced temperature regulation, energy-efficient design, and durable materials ensure reliable performance.
Before launch, every Starlink satellite faces conditions harsher than it will ever experience in orbit. In vacuum chambers, we simulate the cold, airless void of space. Vibration testing replicates the brutal forces of launch. Thermal cycling pushes it to the edge of material failure. If it fails here, it never flies. This is how we ensure reliability for global connectivity. The future of global connectivity begins with innovation in satellite design. The flat design of Starlink satellites allows dozens to be launched at once. This revolutionary stacking capability maximizes launch efficiency. Each launch carries the potential to connect millions more people. This efficiency is key to building a global network at unprecedented speed. Bridging the digital divide, one launch at a time. Space used to be throwaway. Now it's reusable, reducing waste. High payload, reliable performance. Falcon 9 launches with precision. Advanced guidance returns the booster. Efficient re-entry enables rapid turnaround. Falcon 9 launches, lands, and flies again, drastically reducing the cost of access to space. Reusable rockets make Starlink economically possible.
Moments after release, guidance systems awaken, aligning antennas, orienting to Earth, and acquiring the first navigation fix. Microthrusters pulse, and reaction wheels spin, trimming attitude and velocity to settle into the intended orbital plane. Once deployed, satellites maneuver into precise orbits, forming a synchronized network that circles Earth every 90 minutes. Spacing and phasing are continuously managed. Autonomous onboard logic and ground control maintain exact separation. The result: reliable coverage, real-time monitoring, and a scalable constellation orchestrated with exquisite precision.
Starlink is still evolving, bringing high-speed internet to places once out of reach. Faster speeds, broader coverage, and new generations of satellites are already in development. From a factory on Earth to precise deployment in orbit, innovation never stops. Laser-linked constellations cut latency and scale to meet tomorrow's demand. For ranches, boats, clinics, reliable rural access, simple setup, and support around the clock. Starlink represents a new chapter in how humanity connects, one satellite at a time.
Thank you for watching. Join the Makeology community for more fascinating explorations into technology, engineering, and the innovations shaping our future. Hit subscribe, turn on notifications, and stay connected for the next incredible journey.